Hi, this is Sunny Solanki and you're tuned to CoderzColumn. In today's video, I will explain how to create an image classification app using Python library Streamlit. Streamlit is very famous Python dashboarding library and it's the most preferred library nowadays to create a web app or dashboard using Python. For our app, we'll be using a pre-trained PyTorch model. Specifically, we'll be using a ResNet 50 model available from PyTorch. ResNet 50 is a deep convolutional neural network that is quite good at image classification task. The model is trained on ImageNet dataset. So ImageNet is a very huge dataset of 1 million plus images of 1000 different categories. There are images on categories like different animals, fish, fruits, flowers, day-to-day use objects, and so on. Alright, so that was a small introduction. First of all, let me show you the dashboard that we are going to create. So as you can see on my screen, we have our image of the dashboard or app that we are going to create. As you can see at beginning, I have a simple title and the dashboard will have a simple upload option. So we'll be able to upload option by clicking on this browse file. We can upload PNG or JPG image. And after we upload the image, the app will run the model behind the scene to classify this image in one of the categories. So we will be displayed with this bar chart, which will display us the probabilities, top 5 probabilities of what our model thinks. Then we will display the original image, and next to the original image we have output of interpretation. So we will also interpret like which pixels of our model contributed towards the prediction. So we can be sure like whether our model is picking up the right pixels for predictions or not. So this is the app that we are going to create. So before we move on to coding with the dashboard, first of all, let me jump to Jupyter Notebook. So in this Jupyter Notebook, I have included a list of steps which are used to load the pre-trained model, then make prediction on it, and then interpret predictions. And we'll be using much of the code from this notebook when we start with coding of our dashboard. Alright, so as you can see at the beginning of the notebook, I have a few sections which are load model, make predictions, and interpret predictions. Then I have listed Python dependencies, so the libraries that we will need for this tutorial. So we will need Streamlit for creating dashboard. PyTorch obviously we will need, as we will be using a pre-trained PyTorch model. Torch Vision is another module available from PyTorch, which is specifically designed for computer vision tasks. So it has functionality and pre-trained model for various computer vision tasks like image classification, image segmentation, and so on. Captum is another library that let us interpret the prediction made by the PyTorch model. So it's specifically designed to interpret predictions of PyTorch model, and it provides various algorithms to interpret the prediction made by the model. Matplot will be used to display the chart, the interpreted prediction, and that horizontal bar chart. And then we will also might need NumPy. Right. So first of all, over here I have imported all the libraries, and I have also printed that version. So PyTorch is 2.0, Torch Vision 0.15, and so on. Right. So next in this section, load model, I have imported ResNet 50 model from torchvision.models module. And then I also imported weights. So over here I have simply loaded the model, and for weights I have provided ResNet 50 weights dot ImageNet 1K v2. So this is one particular version of weights which we will use. And after loading the model, we have set it in the evaluation mode so that we can call predict method on it to make predictions. So that's why we need to call eval function. So that will load our model. The next line of code simply loads a pre-processing function from ImageNet. So we call transforms function on that weights. And what this function does is that it takes image of any size as input, and it creates it transforms that image for our model. So our model requires images of size 224 by 224 pixels, but we will create an app that let us provide image of any size, and this function will be modifying that image for our model. So it will first resize the image, then it will crop the image according to 224, and then it will perform normalization as well using mean and standard deviations. So this is the pre-processing function which will prepare an image for the model to make predictions. Next, I have created a simple list of categories. So these categories are available from meta attribute of weights, and it has name of the categories. So the output of the model will be probabilities, but we will be converting them to this name, like what is the class, goldfish and white shark and so on. So these are the name of the classes. Alright, so next we will be making prediction. So I have a sample image named shark.jpg which I have kept in my current directory, and for loading this image I have used the PIL module. So PIL is a pillow module available from Python for loading the images and working with the images. So as you can see, after loading the images, I have printed the size of the image is 640 pixels by 475 pixels, and then I have displayed. So this is how our image looks like. After loading the image, I have pre-processed the image. So pre-process funcs of shark. So shark is a PIL object, and yeah, then output of this pre-processing is 3 by 224 by 224 pixel tensor. So output of this function is a torch tensor. The first is channel, then width, and then height. So original image was 640 by 475, but the pre-processed image is 224 by 224, on which our model will make predictions. So next we have used the pre-processed image and make prediction on it. So over here I have called unsqueeze function. So the reason behind calling unsqueeze is that generally model works on a batch of images, and in our case we only have a one image, so we will need to add image dimension at the beginning. So when we call pre-process image dot unsqueeze of 0, it will convert this image of size 3 by 224 by 224 to 1 by 3 by 224 by 224. So the output of the model is dense layer output. So output of the model will be 1 by 1000. So then I have called a softmax function on it. So it will convert this output to the probability. So now props will have an array of size 1 by 1000. So we will have 1000 probabilities. So over here what I have done is that I have indexed it at 0. So we have 1000 probabilities. And then I have called a detach function, and then I have converted it to numpy. So out this props, final props will be an numpy array of size 1000, and it will have 1000 probabilities. So over here I have called a detach function. So the detach function what does is that behind the scene PyTorch maintains a graph when it calculates any function, and that graph is used to calculate gradients when we call backprop function. So in order to call numpy over here to convert our tensor to numpy array, we need to detach that tensor from graph first, then only we can call numpy. So that's the only reason to call detach. Next over here what I have done is I have sorted the probabilities. So this will sort the probabilities in ascending order, and then I have taken last 5 probabilities and then I have reversed them. So I have highest probability at the beginning, and then I have also retrieved the index of those probabilities. So what are the indexes of the probabilities? So as you can see over here, 0.53 is the highest probability, and then other probabilities. So first top 5 highest probabilities and the indexes of those top 5 probabilities. So using these indexes of top 5 probabilities, we can index our categories array, and we will be able to get the name of the categories. So in our case it's saying tiger shark has the highest probability. So as you can see, our model is properly able to predict that this was a tiger shark. It has highest probability for tiger shark, right? So next step is interpreting the prediction of the model. So now that we have made the prediction using our model, what do we want to know, like whether our model is going in the right direction. So is it using the right pixels to make predictions? Is it using the pixel of this shark to make prediction? and not this another object present or some background pixels. So that is called interpreting the predictions. So in order to interpret predictions, we'll be using a Python library Captum, and from that there is an algorithm named integrated gradients which we will load. Over here I have loaded integrated gradients, and then I have given our model to it and saved it to interpretation algorithm. Now Captum has many different algorithms available if you want to try. For our tutorial I have used integrated gradients, but there are many algorithms like deep lift and gradcam and gradient shape, and many different algorithms are available. So if you want to try any other algorithm than integrated gradients, then please feel free to check the documentation of Captum. And I also have a tutorial on Captum which I will share in some time. So there also you can look for different algorithms. So after loading the algorithm, we can simply call a function name attribute, and to this function we will again give our processed image, which was a 3 by 224 by 224 image, and we need to give target, like for which target we want to interpret prediction. So in our case we know 3, so index 3 was a tiger shark, so it's the highest probability. So for that index we want to know like which pixels are contributed to making prediction as index 3 tiger shark. So output of this is another array which is of shape 1 by 3 by 224 by 224, and over here again we have converted it to a numpy array, and then we have transposed the axis. So the reason behind doing this transpose is that we'll be using a matplotlib to display the images, and matplotlib requires channels at last. So as you can see, we have transformed 3 by 224 by 224 to 224 by 224 by 3. So PyTorch models requires channels first, whereas matplotlib requires channels at last to display image. So that's what we have done over here. And after transforming image, over here I have imported visualization submodule from our Captum module, and over here I have called visualize image attr function available from that module, and to it I have given the future importance array that we calculated. And as you can see, it returns the figure object and axis object which we have displayed over here. And as you can see, there are pixels over here dark, which is clearly hinting that these are the pixels that contributed to making predictions that this is the shark. So we can be sure that our model is in the right direction. It is using correct pixels to make predictions. Alright, so that was a small introduction to loading the model and making prediction using it. At last I have references, so if you're interested in Captum, then please feel free to check our tutorial on Captum which is available over here. We also have a tutorial on how to use pre-trained models available from PyTorch for image classification. So I will include links to both these tutorials in the description section. So that alright, so let's go on to the coding part of our dashboard. Alright, so as you can see on my screen here, I have already IDE open, so I will be using a Visual Studio Code for coding purpose. So I have created a file name imageclassif-.py in which I will be keeping code for our web app or dashboard. So I already have some amount of code present over here. So this is the code to load the model and make prediction which I explained in the Jupyter notebook. So let me just go through it again quickly. So at the beginning I have imported Streamlit, and then I have a few imports like pillow import, numpy, matplotlib. Then I have imported torch using imports, the resnet model and weights, and then I have a Captum imports. Next I have kept a pre-processing function over here to pre-process our image, and over here I have categories, so list of categories. Next I have created a simple function named load model. So this function will be used to load our model. It returns model, and as you can see I have decorated this function with st.cacheResource decorator. So this decorator will cache this resource, so we don't have to reload it again and again. So what happens in case of Streamlit is that whenever you change the code of Streamlit file or you change any widget state, so it runs the whole script from top. So if every time we change the script or every time we change widget state, the script will run from top, and we don't want that this particular part of loading the model takes a lot of time. So that's why we are caching it over here. And then I have next make prediction function, which takes model as input and process image and makes prediction on it and returns probabilities and indexes to us. And then next I have interpret prediction function. So this function takes a model, process image and target with respect to which we want to calculate interpretation. And the output of this function is future important, which we will display in our dashboard. Right, so let's go ahead with dashboard coding. So first of all, I will include a title. So I have a function name st.title, and this will create a HTML h1 tag as a title of our web app or dashboard. So I will say resnet 50 image classifier. Now over here you can also include various images. So you need to know the name of emojis, and you need to specify that word inside these two columns. So I know two emojis name which I commonly use, which are tea and coffee. So I will include them over here. But if you want to know the name of other emojis, then you can check the documentation of Streamlit. There are lots of emojis available over there. So now we have title. Next thing we will do is we will create a file uploader. So this file uploader will let us upload file. So I will say upload image. So this will be the label of this widget, file upload widget. And then I will set type argument. I will say VLO, PNG, JPG and JPEG images. So output of this will be the image that we uploaded using this widget. So if upload is available, so this upload variable will have image represented as a bytes. So whatever image we upload using widgets will be available through this variable. So if upload, so some image is present in this variable, then we make the prediction. So first of all, I need to convert image to pillow image. So that I can do using image.open function. So now the upload, which is a byte string, will be converted to pillow image. Next, what I will do, I will load the model. So there we have a model, and now we can pre-process the image. So I will say pre-process func of image. Pre-processed image will be the output. So that's a pre-processed image. So now we have pre-processed image. Let's go ahead and make prediction on it using this function. So I will copy it. First argument is model, second is the pre-processed image, right? And output is probabilities and indexes. So now we have probabilities and indexing since we have made a prediction on our model. Next, let's interpret this prediction using this function. So what I will do, I will call this function interpret prediction. We give it model and then pre-processed image is the second, and for target I will give indexes of 0. So indexes of 0 is the index which has highest probability. So output of this is a future importance. Right, so now we have a future importance as well. So let's go ahead and first of all create the horizontal bar chart, so which will display the top 5 probabilities. So first of all I will create a figure object. So I will say plt.figure and figure size I will set to 12 by 3. Okay, next let's create the axis object. So main figure dot add subplot 111. Next let's call plt.barh function to create a horizontal bar chart. So for y-axis we will give categories of indexes. So this will be the top 5 classes which we predicted, and width of each the bar will be probabilities, and color let's set it to tomato initially, and then we will change it. So now we have a bar chart ready. So, all right, so let me include a title as well, saying top 5 probabilities, location, center, and font size to 15. All right, so now we have created a bar chart, horizontal bar chart showing top 5 probabilities. So in order to include this matplotlib image in dashboard, there is a function named pyplot, and to this function we give our figure object, and there is a parameter named use container width which is available. So we can set it to true, so it will increase the size or decrease the size of the image based on the size of the container. Right, so we are done with the initial dashboard. So what this will do, when we upload an image, it will display us a top 5 probability. So let's just run this part of the code and test it. So as you can see below, I already have a terminal open, and I have saved this file image classif dash.py in this folder Streamlit image classification dashboard. So in order to run the dashboard, we can execute command streamlit run and then name of the file to start the server. So when I execute this command, it will start the server and open a new tab in browser where it will be running this app. So I have executed the command. Right, so as you can see, it's running the app, and now we have our app ready. As you can see, we have a title and we have a small widget to which we can upload files. So let's go ahead and browse through files. So I have kept some files already in this folder of various animals and so on. So let me select this file doberman.jpg. So it's running, as you can see over here. Alright, so it has made predictions. As you can see, Doberman is at the last, and then Toy Terrier and other predictions. So yeah, we have our bar chart ready. So let's just reverse the probabilities and titles. So we have highest probability at the top and others at bottom. So in order to do that, I will simply reverse the list by colon -1 over here. And same I will do for width. And over here for colors, what I will do, I will say Dodger blue *4 plus. So what this will do is that the first highest probability will be colored of tomato, and other 4 will be blue color. So let's just test it. Alright, so as you can see, Doberman is of a tomato color and all other are Dodger blue. So we are done with our initial chart. Now next we will do is we will display the original image, and next to it we will display the interpretation of that image. So let's go ahead and do that. So in order to calculate interpretation of the image, we will be calling viz.visualize image actor. And over here we will give our future importance that we calculated, and we will be saying to display color bar. So show color bar needs to be set to true, and there is a figure size attribute which we can set. So I will set it to 6 by 6, and output of this is a figure object and axis object. So I will say interp underscore figure. So this is the figure object. So this will be the figure object which will display next to the original image. So in order to display the two images or two charts next to each other, we need to divide the horizontal space into two vertical space, and that we can do using st.columns function. And this function accepts integer. So I have given integer as 2, so it will divide the horizontal space into two vertical columns, and there is a parameter named gap, so the gap between those two vertical columns. So by default it's a small, but I will set it to medium. You can set it to large as well based on your need. So the output is two column objects which I will store to col1 and col2. Now in column 1 object, first column we will display original image. So we can use this call object as a context manager Python with statement, and over here I will display the original image. So in order to display the original image, I will again need to create a figure object, matplotlib figure object. So I will say plt.figure. Fig size I will set to 6 by 6, and this is the figure. Let me call it main figure. And first of all I will also create axis object dot add subplot 111, and then next I will say plt dot imshow. So this will be used to display the image, and I will give it this pil image, so it will display our original image. So now that we have a original image, I will also set x ticks and y ticks to empty list so that they are not set. So now we have our figure object ready. Let's display it in dashboard using pyplot function. So over here I will say main fig, and over here I will say use container width to true, so that it expands and shrinks figure based on the width of the container. And for second column, so I can again use it as context manager. So in the second column we'll be displaying our interpreted image. So over here I will simply use pyplot function, and we already have inter figure available to us, so that we can use. Container width I will set it to true. Alright, so we are almost done with our dashboard. So let's test this part of the code and we are done. So let me rerun. Alright, so as you can see, we uploaded the Doberman image, and our model is predicting Doberman, and over here is the interpretation. So it's using the pixels of Doberman itself to make prediction that this is a Doberman. So let's try a few more images which I have. So let's try this dog. So as soon as I upload an image, the model runs behind the scene, which makes the prediction like which category of all the 1000 category this is the image of. So this is predicting it as a golden retriever, and as you can see it's using these pixels over here to make the predictions. Right, so let's try a few more. Let's try this image. So this is the image which I have of our dashboard or our web app. So let's see what it's predicting for this one. Right, so wow, so it's predicting that it's a website, and Doberman is also one of the top 5 probabilities. So it was able to predict that this image is of a website In our case, it's our image classifier app. And there was also Doberman in this image, so it was able to detect that as well. Yeah, so that's it. We are done with our dashboard. As you can see, we were able to create this dashboard in less than 70 line of code. So it was that easy to create a web app or dashboard using Streamlit. So yeah, that's it. Now I used ResNet 50 classifier model in this tutorial, but you can use many different models available from PyTorch, whichever you feel like is giving good results. Other than that, you can also try many different interpretation algorithm for Captain. Yeah, so that's it. If you have any doubts about this tutorial, then please feel free to let me know in the comment section. If you liked our video and you feel that you learned something new today, then give it a thumbs up. Subscribe to our channel if you're looking for more tutorials on topics like Python, machine learning, AI, data science, and so on. And yeah, see you next time.